Hey guys, Howard here with MakerDaddy.com again. And today for lesson 5, we're also going to be working with LEDs. The difference today is we're going to be using multiple LEDs. We're having two LEDs in a series circuit here and then two here. So we have left and right LEDs. And we're using a push button. So let's go ahead and talk about that a little bit. So the way the circuit is going to work here today is we have on the push button itself, we have one jumper connected to ground, one jumper connected to 5 volts, and another jumper, this orange one here, is connected to pin number 2. And in our code, we'll have this set as an input. So what happens is when I push the button, currently in the state right now with the button off, it's sending a high signal. When I push the button, it sends a low signal to pin 2, and in our loop function in the code, we're actually going to be looking for that to detect when it goes to low, and when it does, we're going to call pins 13 and 12 here. We're going to send a high signal there. We've seen that before in other lessons where we have the digital pin connected to a 330 ohm resistor, and that 330 ohm resistor goes to the positive, the long leg on the LED. The short leg here on the LED is connected to the other LED. If we see here, we come back over here and we're connected to this lead. And the same thing here. So we have pin 12 connected to this resistor, connected to this LED, and in turn we have a jumper going to this LED and then back to ground. So these are basically the same as what we did before, just instead of one LED, we now have two connected. The whole purpose of this is I want to eventually simulate a railroad crossing, in which these two LEDs would represent the lights on a post, the signpost, and these two LEDs would represent the lights on the crossbar. So when the lights start flashing, the train's coming, the lights start flashing, and then the servo motor will bring the crossbar down like this across the road. So in order to do that, I want to first work on the LEDs, and I want this to work off of the switch. So when I push the switch, that's when all the action happens. Okay, so this is our first lesson. This is going to take into a piece of the project into account. So when we push the button, we see that two LEDs light, they flash and they go on and off. When I let go, it stops. So what's happening here, and another thing to note is on this push button, we have what's called a pull-down resistor. This is a 10,000 ohm resistor connected between the switch here and the ground. All this does is prevent noise. When you're pushing the push button like this, you can actually get a little bit of noise there when it's like connecting and disconnecting a little bit there between ground. You just want to get rid of that. Okay, so that's what this resistor does. All right, let's go and take a look at the code. All right, so here we are in the code, and this is for lesson 5, and we're going to look at the top part here. We're declaring some global variables. These are all constants, which means they will not change throughout the course of our code when it's running. The first two here are for left LEDs we saw on the board. This one is for the right LEDs, and then for the button pin number 2. Here we have some constants for our on period and off period. I can change these if I want, but right now we're just using half a second. This is not a constant, but it's still a variable. This is button state. This will actually change every time we push the button and let it go. All right. So in setup, we're setting our serial port to 9600 baud again. We're going to just output something a little bit later. We're setting pin mode on the left LEDs to output. We're setting the pin mode on the right LEDs to output. We're setting the pin mode on the button pin to input. We're actually going to receive a signal from the push button. Okay? In loop, the first thing we're going to do is we're going to read the state of the button, the button pin. So what's going to happen is instead of calling digital write like we do with the LEDs, we're calling digital read because we're actually going to be listening for the signal. We're going to read the signal, and when we do, we're going to assign that value to button state. So the signal will either be high or low. Okay, it starts out as low, which means that the button is not pressed. Okay, so in our code, we're going to find out what the button state is. Is the button up or is it down? We're going to say if the button is pressed, that means the button state is high. I'm going to write this out to my serial monitor just for fun. Then I'm going to turn the LEDs on. So what I'm going to do is I'm going to call this blink light function, passing in the left LEDs That's pin number 13, on period of 500 and off period of 500. Then I'm going to do the same thing, called blink light again, for the right LEDs. Blink light, all that is a function we had in a previous lesson where we take the pin number on and off, and we actually just digital write to that pin. High means we turn that light on for this amount of time, which is 500 milliseconds, a half a second. And then we turn it off here, and then we delay that for another half a second. So we do this, basically we turn the left LEDs on for half a second, and then we turn the right LEDs on for half a second. And when we actually let go of the button, this is else, so if the button stays high, otherwise, this else statement means otherwise, go ahead and turn the LEDs off. So we call lights out on the left LEDs and lights out on the right LEDs. And all that is just digital write low. So if we're in the middle of something, we let that just set it to low. And as we saw in our previous video, this is a simple, very simple circuit with a push button. And what we want to do is we want to actually be able to have multiple processes working at the same time. And we're not going to be able to do that when we're using delay. So in our next code, we're going to actually look at using the push button so that it works as a toggle switch, and so the lights work without actually using delay. We're going to be looking at using milliseconds in the next lesson to determine if the light should be on or off. All right, thank you very much. I hope you liked this lesson. You can leave comments below, and hope you like and subscribe. Thanks.